two concurrent forces. The concurrent force nothing but the forces that are acting through one common point. Suppose these are this. So if this is a point, there are different forces acting on a point, then the such points are known as concurrent forces. The two concurrent forces are acting at a point as shown in the figure, and the magnitude and direction of the resultant force. Suppose there are two forces here, and the angle between them is 45 degrees in some particular case, practical case. Somehow the vectors acting like this with an angle between them. Now he is asking the magnitude and direction of the resultant force. As I said, there are two methods. Let's go for vector method as per the handbook. So what is the procedure? First find the F1, write it in the vector form. What is F1 and F2? They did not mark it. So I mark this as F1, this as F2. You can mark it as per your convenience. It can be the answer, final answer will be same. So I marked it as F1 and this is as F2. And now F1 is equals to Fx I cap plus Fy j cap. What is Fx? X component F cos theta x. It is there in the handbook. It is there in the handbook. So again, the procedure is same. Draw a parallel imaginary rectangle. So with the question to question, I keep on decreasing the steps. I will skip the steps, but you guys should be practicing thoroughly so that you will follow my steps again. So what is theta x here? Theta x is 45. Theta y is also 45. So F1 I got it this as this I cap plus this j cap, and the sign conventions are obviously these components will be plus plus. So I got it this F1. Coming to the F2 component, this is F2. So I mark the diagram again. I neglected the other forces. If this is my F2, it is along the x direction itself. You cannot build any components. So I can simply write F2 as 900 I cap. Since it is along x direction, it is on 900 I cap. But if you want to be very clear, if you want to learn from basics, go from the beginning. So Fx2 I cap plus Fi2 j cap, because I denoted as F2. So that's why I'm using this suffix here 2. And then the angle here is theta x will be 0 because it is already along x-axis. So angle made by this will be x-axis will be 0. And with y-axis, it is making an angle 90 degrees. So cos 0 it will be, cos 90 it will be, cos 0 is 1 and cos 90 is 0. And then you find you get the final as this. You can, instead of doing 1, 2, 3 steps, you can directly mark this visually seeing this. Suppose if my vector is along this direction, around 300, I'll keep it as 300 j cap. That's it. Very simple. Once you got the Fx and F1 and F2 in the vector form, as I said, it is not there in handbook, but I suggest you to do this. Just simply add these two vectors. How to add two vectors? It is properties of mathematics. So adding two vectors is nothing but adding the corresponding components. So keep the I here and add all the x components. So this is 254 and x component is 900 here. So add these two. And for the j component, add all the j components of each vector. 254 plus 0 it will be. So if you see here, the same thing I have explained, it will be 0. The final vector is this. After getting the final vector, as I said, that resultant of a vector a I plus b j cap is under root of a square plus b square. It's nothing but the formula that is given here. It is indirectly, they made it bigger. You can go this step or you can follow just simply these steps, you get the resultant. Coming to the angle, as I said, the angle with the positive x-axis, the formula is given as tan inverse of this by this. So you do this by this, or if you want to do the formula, you keep on spread this sigma and then add each and every term. You will finally end up with the same expression. You will get this angle as 12.43 degrees. So this is how the resultant is. If you want to know how this resultant looks like, you can just see this 12.43 degrees and mark it here with x-axis. This is my x-axis. So here somewhere, mark the line like this, and it will be like this, and it will be 12 point some degree. And the magnitude will be what the magnitude we got? We got it as 1182. So this is the resultant vector of the two vectors. So this is it, guys. Let's see an example here. Two concurrent forces are acting at a point as shown in the figure. The magnitude and direction of the resultant force are most nearly. And the figure looks like this. There is one vector and there is another vector. By graphical method, if you want, as I said, draw a imaginary parallelogram by drawing the lines parallelly, form a diagonal. After forming diagonal, the length of the diagonal is nothing but the resultant. Apply in the formula. In the place of f1, place it as 360. In the place of f2, place it as 900. Even if you take it as f1 and if you take it as f2, you will get the same answer, because the choosing the vectors, the forces as 1 or 2 is our choice. So this is the case, and you know theta here as a formula as I shown in the previous page, somewhere here. So copy paste this formula, then you will get the answer theta as 12.43 degrees. This is through the parallelogram law, but in the handbook we don't have the parallelogram law. We have the standard formula. Using this vector form, you can resolve the given forces into vector form and again apply the same principle. Or else,
Facing the challenge of the FE exam, looking for a way to prepare smarter, not harder? Bhavanam's C2C has the answer. Introducing Bhavanam's C2C FE exam preparation program, designed for civil engineers aiming to pass the FE exam and excel in the USA. Wondering what sets us apart? Our expert team. Meet Mahendra, EIT and project manager, who knows the FE exam inside and out. K.N. Mathur, EIT and civil engineering master's graduate. And Chandravarthan, IIT postgraduate and top 422 GATE rank achiever. These experienced instructors have already helped hundreds succeed. Will you be next? In just 3 months, you will master all 14 essential subjects through live online classes held every evening from 8:30 to 9:30 p.m. Monday to Friday. But that's not all. For each subject, sharpen your skills with 15 dedicated practice questions and follow up with quizzes containing 45 questions to solidify your understanding. Prepare like a pro with 3 full-length, 6-hour mock exams designed to mirror the final exam. Plus, receive personalized guidance through one-on-one sessions with our expert instructors to refine your strategy. We understand balancing work, life, and studies can be challenging. So we have got you covered with 1 year access to recorded sessions and replays of live classes to catch up anytime. Here's the game changer. While others charge over $1,000, we are offering everything for just $350. Want an even better deal? Contact the number below now to claim a flat $50 discount and get it all for only $300. Enjoy a 100% refund if you are not fully satisfied within the first week. No questions asked. Our live batches starts fresh every month on 15th. Don't miss your chance to join. Limited seats available. Contact the number below to secure your spot and get enrolled today.
see the next example here. There are 3 forces acting in a plane. Find 900, 200 and 360. What is the resultant force, magnitude and direction? So actual procedure is very simple. If we want to use a parallelogram law, there should be only 2. If there are more than 2, that will be tedious. So avoid parallelogram law. The main other formula we have as per the handbook is the vector form. For each and every force that is acting, for right, F1 is equals to some Fx I cap plus Fy j cap, then F2 is equals to Fx2 I cap plus F2 j cap, the F3 is equals to so and so, and then F resultant is equals to simply the sum of all individual vectors. Summation of vectors is nothing but I cap, it will be I cap, and here it will be sum of all x components plus j cap and sum of all y components, and then F resultant is equals to under root of a square plus b square, so and so it is repeated. But if you want to avoid all the standard procedures and start doing with shortcuts, with the practice, we can cut short the routine procedures. So then how to do this means, simply what you can do, you can convert this bigger problem into simpler problem. Like if there are 3 vectors here, you can convert into simply 2 vectors. How? We can convert this 360 newtons into the components of x and y first. So if it is 360, its s components will be 360 by root 2, because you know fx is nothing but f cos theta x. So what is f here? 360 into cos theta x is nothing but cos 45, and this is 360 into 1 by root 2, that is nothing but 360 by root 2. This is again the topic of resolution. Again, you need not to remember each and every step. Every process should go in your brain, and I have directly written here the x component as 360 by root 2. Similarly, the y component here, there will be 200 acting. Along with that, the y component of this force, that is again 360 by root 2, because here theta y is also 45 degrees. After breaking this, now the question is has become simpler. It is now only two vectors that are perpendicular to each other. They are simply along x and y directions. So along x direction, what is the total magnitude? It is 900 plus 360 by root 2. Along the y direction, it is 200 plus 360 by root 2. Use the calci, simplify them. Now, if there are only two vectors along the x and y directions, the resultant is nothing but under root of fx square plus fy square. Simply do this, and tan theta will be tan in the theta, the angle made by the resultant will be tan inverse of fy by fx. So here fy 454. So place 454 here, and then denominator will get this answer. So as you keep on practicing, you need not to follow the general standard book procedures. We can cut short the steps. Similarly, if I consider this example E.14, suppose there are three vectors here, 1, 2, and 3, and now I want to find the resultant. As I have been repeating, the standard procedure is first method, vector form, write each and everything in the vector form, and then add the individual vectors, then do the procedure. The second thing, parallelogram law, if there are two, then it will be easy. If there are more than two, avoid it. The third thing is cut short all the procedures, simply bring only the vectors along x direction, y direction. So what I can do here, I am not even drawing the figure now. What I am drawing? Fx is equals to 900 newtons plus this. For this, because of this vector, its x component will be 360 cos 30. So remember this, if this is this, so this will 360 cos 30, simple. And because of this vector, this x component will be in the other direction, so it will be negative 200 cos 60. So simply I got the fx direction. Now coming to the fy direction, because of this cannot get any component, so it is 0 plus, because of this vector, it will be 360 sine 60, 360 sine 30, and because of this, its component will be here, so it will be 200 sine 60. So you guys, if you are not able to follow me, please practice it again. So you need to be too fast here for the cut short methods. So now I got the fy. Once you got the vectors along the y and x directions, you simply do under root of fx square plus fy square. That will be the final answer. So that's how you need to cut off. Finally, when you got the resultant vector, how does it look? If you want to draw it, just draw the x and y axis. And now, whatever angle you got, you mark that angle from there, then mark a straight line and end it till it is equal to the magnitude of the FR you have calculated, that is 353 newtons. When you get this here, so this is your resultant. So please practice, everything will be easy for you.